All right, so good afternoon, everybody. So this is officially TechBits 3, and as I mentioned, I'm going to spend a bit of time reviewing from the prior sessions, and then we're going to go to the next step as we're examining the whole issue of how do we get Excel to do all the hard work for us and getting good information and answering questions from our student data. So I'm going to go through the review section, the review items a little bit on the quick side, just so we get to the new content. But I will be very happy if you need to stop me and ask questions like, hey, can you do that again? Or whatever the case may be. You just let me know. I will be happy to do that. All right, let me move some things out of the way. All right, so when I am looking at student data, which seems to be something I'm just doing all the time for the last years and years and years, there are always just a few things that I do every single time. There's certain techniques that always come up as being essential to getting good information out of data. And the first one is, of course, naming ranges. That technique alone, if I were to say what's the number one thing you should do when you're first looking at student data, it's giving the data its own name, naming those ranges. So we know that up here in the upper left, every cell has some kind of a reference that Excel gives it. It's by row and by column. But when we're trying to get information, sometimes it doesn't really make a whole lot of sense to say, give me C3 through that and find this information in that range. It just makes a lot more sense, makes everything so much easier if we give things names that make sense. So we're going to start there, and then that is going to make everything else much, much simpler. So right now, this is C5, and you see it in there in the upper left, it's C5. We can actually give the whole column its own name, which we can then use to make everything else easier. So let's call this one. So that whole range right there, I'm going to give it its own name, student sex. So if I ever need information about, males and females and so on like that, I can simply refer to the name that I gave it. And that name represents this set of data right here. And let me just go ahead and rename that column. Something that I always do because it just helps me remember, like, what did I call that set of data? We're going to call this one grade. I'm going to call this one spec ed. And as you can see, it's as simple as highlighting the data, going up to the name box, and just typing in the name that I want. And when I hit return, that set of data is now given a name that makes a lot more sense. And as you can see, it is really, really fast and easy to do. So what's the first thing we do when we're trying to get information from data? We name our ranges. I'm going to call that one scores. So let me rename that up there. All right. So that's essential technique one for sure. So let's actually start getting some information here. Well, one thing that Excel is really good at is just counting. So let's start with a very basic question, which is, how many kids do we have here? Or how many rows of data do we have represented in our data set? So let's just count them. All right, so it turns out there's a very simple way to do that. The Excel formula for just counting how many do we have is count A, as in count all, and then we put in some kind of a range of cells there. So count A is what it's going to do. It's going to say within that range, how many cells have something in them. And it will give us that number. So when I use that in my formula, count A, how many kids, equals count A. And I've already named my ranges, so I don't have to say C5 through C45 or whatever it is. I'll just say, for example, well, student sex. And you'll see that in the formula, it colored the name there, which tells me that Excel recognizes it. And in the data set, it's highlighting that range as well. So how many kids do we have here? We have 40 students represented here. And it is as simple as that. Now, so that's nice, how many are we talking about? But we often want to know something a little more specific than just how many. So let's apply some kind of a criterion to that count there. Let's start subdividing it into subpopulations. And a very simple and common question is, well, how many boys do we have? How many girls? So we need to be able to look at that list and figure out how many of those are M, male, or F for female. So we've got a criteria. In order to count just how many times does it come up, we're going to use a very simple formula called count if, like count something if it meets this particular criterion. And it looks just like this. Count if, and then we're going to say, where are we counting? And what are we looking for in that? So in this case, if we want to know how many males and how many females, we're going to look at the range of student sex. How many times does M come up? How many times does F come up? So let's do that. Equals count if, so count the items if they meet this criteria. Our range, we could say C5 through C44, whatever the last, C44, but we gave it a name. So let's just put the name in there. So in the range that we called student sex, how many of them are, now there's an easy way to do this and a really easy way to do this. So here's the easy way. I can just type in, look for an M, and there's 21. Now you may have noticed I did something a little tricky there. Let me show you what I just did. So we've got our count if, right? We've got our range, and then we have a comma, and you see that I put the M in quotation marks. That's simply to tell Excel, this isn't a number that we're looking for, it's actually text. It's a string of text that we're looking for, and to designate that, we've got to have quotation marks around it. We can put a number in there, we can put a reference to another cell in there, but if we're going to use text, we've got to put quotation marks around it. And what does that tell us? So look in the range student sex, tell me how many times M comes up, and it's 21. So that's a simple way. Here's why there's an even simpler way than that. Looking ahead, I know that I'm going to want to know how many female students there are also. And I'm just going to say males, females there. Change my question a little bit. Well, I could simply retype the formula, count if student sex equals F, right? But I've already typed it once. So I don't want to type it again because it's not efficient. So I'm going to make a little change right here. Instead of saying look for M, I'm going to say look for whatever that value is directly above it. And the cell right above it has an M, right? So it's going to look for whatever's in that spot right there. And I'm going to put that into my formula instead, and it should give us 21. Here's where it makes things simple. I can take that formula and simply copy it over to the right. So instead of looking for the M, which is directly above the formula, when I move the formula over to the right, it's going to look directly above it and it's going to find F. So instead of saying find the F's, it's going to say the formula is going to basically mean find the value that's right above me, whether it's an M or an F. So I can simply take that formula, which I have written once, move it to the right, and now it's going to tell me the numbers of females. So it makes things even simpler. So you'll notice when I highlight the formula, now it says, look in the range called student sex and find what's directly above it, which is an F. So I now have the numbers of males and females. I only had to write the formula one time, which is lovely. All right, so let's just do one more variation on COUNTIF. And of course, this is all review. So males and females, let's see, what do we want now? How many scores above 500 for both males? Let's do not males and females. Let's just do one, because with COUNTIF, we can only use one criterion. So let's just do one more. So equals COUNTIF. Now, we're looking for scores. So what's the name of the range for scores? Happily, it's just scores. And what am I looking for? I want to find greater. So where's my greater symbol? Greater than 500. And there are 23 scores above 500. And I had to do something a little different there. And it goes back to these quotation marks. When I said I want greater than 500, I'm actually telling Excel two things. Excel has to look for two things. It has to find this value here, and then it has to determine if it's greater than that. So we're doing two actions there. But we can only have one criterion. So to tell Excel that these two parts need to work together, once again, I put the quotation marks around it. So a number, fine. A reference to another cell, fine. But if I'm going to do greater than, less than, not equal to, then I need to put the quotation marks around it. And right away, it has told me that we have 23 scores that are above 500, which is pretty cool. Now, I wasn't able to do males and females on that because COUNTIF only gives you one criterion, and our criterion was above 500. If we want multiple criterion, we have to use COUNTIFs, and the only difference is there's an S at the end of it. COUNTIF, one criterion, COUNTIFs, multiple. And I think, if I remember correctly, you can have something like 256 different criteria, which is kind of wild, actually. You can have that many. I don't know why you'd ever need it, but you could if you really wanted to. So this one is going to look a little bit different. It's going to do the basic same thing. Look for the criterion, tell me how many times it comes up. But for the COUNTIFs, we have another option available to us. And let's see how it works. So equals COUNTIFs. And you'll see that we can simply start stringing together ranges and criteria, one after the other. So it's pretty similar to what we just did. So you've got a range to look in, and what's the criterion? Then another range to look in, and another criterion. And just keep going as far as you want. And Excel will tell me how many times the multiple criterion have been met. So for example, we've got how many ELL SPED males we've got. So how many students are male and ELL and special education? We have 3 criteria. So we're going to have range criteria, range criteria, range criteria. Let's try it out. So count if. We're just counting how many times these criteria are all met. Nothing about the values, just how many are there. So count ifs. First criteria range, ELL, comma. And what am I looking for? Well, 0 for not or no, 1 for yes. So how many times does the number 1 show up? Comma. Now my second range, I want spec ed. How many times does 1 come up? And I want to know males and females. So under the range student sex, comma, and I'm going to do what I did before. Instead of putting in M or F, I'm simply going to click on the cell above it and say, look for whatever's in that cell. And then close it. 2. And because I'm referring to that cell above it, when I move the formula over, it's going to look for F instead of M. So right. And there are 3 female ELL special education students. I'll go ahead and do the next one. Why not? Okay, equals count ifs. So we want ELL is 1. We want student sex is comma, whatever's up there. And just like with count if I have a criteria that's greater than or less than or not equal to, I'm going to need to put quotes around it. So scores, comma, quotation, greater than 500. And then I can move it across to the right. There are, interesting. In this data set, 2 male students, ELL students, have scores above 500, but seven girls. Now we're actually starting to get something interesting here, because then we can ask, we've got a real difference there. What do we need to do differently? Or what might be happening here that needs some further study? So those are all that's the review of all just the basic counting functions. So let's start doing some calculations now on the values, right? That's just how many times does this show up? But we've got some real values in there, numbers of absences, their scores, and so forth. So let's start doing some things that actually start finding values. Well, obviously the simplest one of all, pretty much any time we're looking at data, at some point we're probably going to find the average. What is the average? And in this case, I'm going to look for the average of all the scores. All right, what's the average score? By itself, I would just caution by itself, just knowing the average isn't very meaningful. We're going to have to start looking at some subgroups, and eventually towards the end, we're going to look at standard deviation, which will tell us, is the average useful to us or is it not? So average, and what range am I looking in? Scores. All right. So the average score is 538.5. But averages are tricky because the larger the data set, sometimes the less useful that average is, because you just have so much variation in the data that the average isn't a good indicator of what's actually happening with the kids. But we will come back to that. All right, so that's average. All right, but let's start subdividing or start looking at special populations, or looking at the data a little more specifically by incorporating some criteria. Let's start pulling out specific pieces from the data and see what we can learn there. So just like we did count all, and then we did count if or count ifs, we can also do average if. like average the scores if it meets a certain criterion. And there are three things that we can put in here. We only are required to put in two, but there's three that we can put in here. So average looks like this, average if. Average if. The first thing is, well, we're going to have a criterion, like which scores do we want to average, right? So where are we going to look to decide whether or not to include a particular score? What's the range? And then what are we looking for? So for example, we could say, look in the scores range of data and average up all the scores over 500, for example. So we'd only need that. Where are we looking and what's the criterion? But more commonly, we are looking for some criterion to identify particular types of students, and then we're going to go get their corresponding scores. So we're going to find our criteria in one place, like which type of kid are we looking at, and then average up their test scores or their absences or whatever it is that we have in our data set. So we have a third item to put in here, which is range to average. Where are the items that we're going to average up? So where are we looking for the criterion? What is the criterion? And where are the values that we're going to average? So what have we got here? Fifth grade scores. So equals average. Okay. We are looking for, in the grade column, we are looking for a 5, fifth grade. And if you find it, where is the corresponding value that we're going to average? Scores. So look across the fifth grade column. When you see a 5, go get the test score and then average it in. And that's too many decimals. Average grade 5 scores. So now when we calculated average above, it starts to get a little bit more interesting, because what we see here is those fifth graders are way behind, way below the average of all scores.
Excuse me, David. You didn't need to type in average if, you still just type in average and then the two criterion?
I am busted, as you said. Thank you very much. Average if. There we go. Yes, you are right. So average if, thank you for that. So grade 5, and look at their scores. That's a little better. Okay, but they're still behind. But you're right. I missed the if there. So, and I'll tell you, that actually makes a good point. So I'm glad you caught me. If I get a finding like something doesn't look quite right about that, which that was really low, I can go back and just double click on this cell and I get my formula again. And not only can I see what I'm asking Excel to do, average if, but where the Excel is looking and what it's performing the calculations on is really obvious because I've named my ranges. So if I get a screwy result and I'm like, well, it says C4 through C55, whatever it is, that doesn't mean much to me, but I'm like, oh, I'm looking at the grades. And have I built my formula correctly to give me the answer that I want? So, so A, thank you. And B, it does make a good case in point that naming ranges makes the rest of this a lot easier to understand. How's that for a good save? All right. We can do the same thing, average if ELL is 1, and give me their scores. Okay. That's actually kind of interesting. The ELL students, while they are performing on average below the overall average, the ELL students, all in all, are outperforming the fifth grade students, all in all. Might want to look at that at some point. Okay, so that's one criterion. average if. But as with count if and count ifs, sometimes we need more criterion. So I built a little table here that's going to ask about two things: student sex, male or female, and their grade. And let's average it by sex and by grade. And this is going to give us a chance to do something a little bit tricky, but very useful. But let's just start with the basic formula. So the formula is, it's going to be average ifs, multiple criteria. And the first thing it's going to ask me is, what's the range to average? It's going to start there. And then range for, or let's call it criterion range, criterion range, criterion, and we can just keep stringing them up until our eyes bleed, basically. Same thing as before, but it gives us the chance to do multiple criteria. So let's do one very simply, and then let me talk a bit about sort of the planning ahead and how we make it even more efficient for us without having to rewrite formulas. All right, so let's do the basic thing. So let's just look at average score for male fourth grade students equals average ifs. All right. First thing it's going to ask me is, all right, after we do all the criterion later, what are we averaging? And what we're going to average is their scores. All right, comma. Now let's build the criteria. So where are the first criteria? I'm going to do student sex. And what am I looking for? As before, instead of putting in M with quotation marks, I'm simply going to click on the M that's directly above it and say whatever that value is, that's what I'm looking for. Okay. Now let's do our next criterion, comma. So now we are also looking for a grade. So there is a data range called grades. What am I looking for? Whatever is over there in J25, which in this case is a 4. So I'm looking for grade 4. And we'll close it. Fourth grade male students, average score 535.1, which interestingly is almost exactly the average for all the students, which is 538.5. It's only off by a few points. So I know that I'm going to want to take that same formula and use it for the other cells in my little table right there, preferably without having to rewrite it, because I'm trying to be efficient and let Excel do all the heavy work. So what I did previously is I just said, all right, we're looking up to males. Let's move the formula over. And now it's still looking at whatever's above it, which is F for females. So let's try it. And it's going to fail. Cannot divide by 0. What just happened? So here's the problem. When we move the formula over there from column K to column L, the formula, when it's looked for student sex, says whatever's above it, that's what I'm looking for, M. And it will do the same thing with females. But it doesn't just move that reference. Under males, it's looking for the cell directly next to it to the left for the grade. It says whatever's right there to the left, go get that. That's the grade I'm looking for. But when we move the formula over, it's still looking to the immediate left to find the grade. But what it's going to find is 535.1. I need it to find 4 for fourth grade. So we have to do something a little more sophisticated. Let me show you how this works. So here we've got, I don't know what it's called, J25, right? When I move it over from, so this is column and that's row, right? Okay, when I move it over, instead of looking at J25, it's now going to look at L25, which is great because this was males and this was females. But when it's looking for the grades, it's saying to JKL, yeah. When I move it down here, if I move it down, it's still going to look in J, but now it's looking at row 26. And if I move it over this way, it's now going to be looking at J, K, L. If I move it down, L26. Because the way Excel reads references, if you say, hey, start here and refer to this cell over here. So we start here and we refer to this cell over here. If I move the formula, it's still going to go the same number of rows over or back and the same number of columns. And I don't want it to do that in this case because the grade, wherever I move the formula around, up, down, right, or left, the grade is still must stay in column L. I'm sorry, column J. So if I move the formula, I need it to still go back to column J. I need to create something called an absolute reference. No matter where I move it, that's where you need to look. And the same thing with males and females. If I take a formula and I move it down, I still need to go back and look at row 24. So if I move that formula anywhere, regardless of where I move it, I need it to be that row 24. So I have to make those absolute. Turns out there's a really easy way to do that. So let's take our example. So we got J25. So let's say this has to stay in J. No matter where I put it, I need to look in column J. All I have to do is put a $ in front of it. Or let's say I've got my J25, and no matter where I move that formula, 25 must be row 25. It has to be that row. I put a $ in front of it. So no matter where I move it, it's still going to look in row 25. And if for some reason, J25, that I want to make sure it always looks at that cell, then I've got a $ in front of both of them. So no matter where I put the formula, it must look in J25. It's creating what's called an absolute reference. Not from here, it refers in a certain number of rows and columns, but it always refers to the same place. So we have to think ahead a little bit when we write these formulas. So let's see what we've got here. Let me just copy that and let me put it up here. Can't do it. All right, so what do we have? Score, sex, K24. So with student sex, which is K24 currently, I know that no matter where I move this formula, I have to stay in row 24. So let me put a $ in front of that. Now K can change. I'm going to move it over from K to L, from M to F, right? So that can change, no problem there, but the 24 has to stay. And the same thing with the grade. The row 25 can change because I'm going to go from 25 to 26. And if I had more grades, 27, 28, 29, and so on. But it must stay in column J. Absolutely must be column J. So I'll put my $ in front of J. So we have to kind of think ahead a little bit, right? What am I going to do with this formula so that I don't have to keep writing it over and over again? Let's see if we've solved the problem. So let's start first by moving it over. Aha, we have a real value. And I'm going to copy both of those straight down. And now we have, by student sex, by grade level, the average score. So we're thinking ahead a little bit on that. But that's how we solve the problem of creating tables and moving formulas around without losing the information we're trying to find. Whew, it's a little bit heady, but that's how it's done. I will tell you a little shortcut though, while I'm thinking about it. So let me go back to K24. If you want a shortcut, you're typing on your keyboard. I don't want to have to like shift and find my 4 to get my arrow and put it in the right place. I could simply hit my F4 key and it'll make the whole thing an absolute reference. I can hit it again. It makes the row absolute, hit it again. It makes the column absolute, hit it again, and nothing is absolute. So you could just cycle through it like that until you get the one that you want, or you can type it yourself, either way. But in nothing flat, I can now build myself a little table that are addressing multiple criteria at the same time. And that is average ifs. That is actually really interesting right there. So the average of all scores is 538.5, but look at those fourth grade girls, 642.3. And then the males, what do we have? 535, 575, that's pretty close. Fifth grade females, 436. Whew. So as a researcher or somebody trying to analyze the data, I'm going to look at that very carefully. What in the world happened to the girls in fifth grade? Because they are far below the average, and they're the lowest subset of all. And that is valuable information for me if I need to make decisions about instruction or programming or what's going on here. Okay. So that's average ifs. Now, there's another little formula, which is super powerful, but little known and little used. That's going to give us some really critical information, and it's called sum product. And sum product does exactly what it sounds like. Sum, if you add up two numbers, the result is called the sum. Okay. Product is the result of multiplication. 2 times 3. The product is 6. So we're going to do some multiplication to find our products. And then we're going to add up those products to create a total, sum product. Here's how it works. And then we'll see just how powerful it is. Here's what it does. Let me, I've got an example over here somewhere, probably. There we go. So the way sum product works is this. It's going to look at all of your lines of data, and it's going to see if those lines meet certain criteria, and then it's going to give us a value for that line. With a count and the count ifs and all that, that's just how many times the criteria are met. But it doesn't tell us anything about the value of those criteria. So let's say we want to know total absences for a certain subgroup, or we've got absences on our sheet, or the scores for subgroups of students. We need to be able to look at every line, see if it meets the criteria, and then add up the number of absences by that line and do it for every single line, which can take a while. Excel makes it wickedly simple. But here's how it works. So we're looking for fifth grade students. Let me come down here to that one. So we're looking for fifth grade students, males, and we want to know how many absences in total. Not how many times do we have fifth grade males, but collectively, how many absences do they have? So sum product is going to look at the first line, and it's going to say, is this a grade 5? It is. So let's give it a value of 1. It meets the criterion. Is it a male student? It is. Let's give it a value of 1 for true, right? Fifth grade, true, give it a 1. Male, true, give it a 1. And then how many absences? 3. So what it's going to do, it's going to multiply 1 times 3 is 3. And it's going to do the rest of the rows. So yes, that's a 1. No, that is not male. So we're going to give that a 0 times 2. So 1 times 0, 0. times 2, 0. That's not male, so that's a 0. That's not 5th grade, so 0. That's not male, so give that a 0 times 3. 0 times 0 times 3 is 0. Then so that's that one, and now we look at the last one. That's 5th grade, give it a 1. That's male, give it a 1, and times 4. So 1 times 4 is 4. So it does that for every line of data, and then it adds them up. 7. 5th grade male students have a total of 7 absences. Could you do it by hand? Yeah. Do you want to? No. So let's see how it works. So what do we have here? We have total absences for 5th grade students, ELL, male and female. All right. Sum product is going to look like this. Product. Now, each of these checks for the criterion, for each criterion, needs to be in its own set of parentheses. Because it's going to do a little math, right? It's going to assign a 1 or a 0. So it's going to do a bunch of different checks, and each one of those needs to be in its own parentheses. So you see 2 parentheses here. So in this case, we're going to be looking at the grade, the student. Does it or does it not equal 5, 5th grade? All right, so that's going to get a 1 or a 0, and we're going to multiply it by whatever's in the ELL range. Is that a 1 or not? And multiply that by student, come on, Bowman, sex. Does it equal whatever's right above it? So it's either going to be male or female, right? And once you've done that, multiply it by whatever value is in that right there and close it. So it's going to allow us to perform multiple checks for every line of data and then give us the value for that line of data. Let's see how it works. Equals sum product. So we have grade equals 5 times, does the ELL equal 1 times student sex, does it equal whatever's right above it, up there? And after all that's done, multiply it by absences. And I don't even need the parentheses there. And this should tell me, look at, it'll go through every single row in those ranges. 6. 5th grade ELL male students have a total of 6 absences. And let's scoot it across to the females. 7. All right, so a little bit of a difference there. It's not commonly used, but it is a superior strategy for coming up with values that meet multiple criteria. As it turns out, there is another formula which can do the exact same thing. And I don't like it as well, honestly, for 2 reasons, which I'll tell you in just a moment. But it's called sum ifs. So sum ifs is basically going to say, what are we adding up? And then it's going to say, well, what's the criterion range we're looking at first? And then what's the value, or what's the criterion we're looking for? And another range, another criterion, another range. And it'll do kind of the same thing. It'll do checks all the way across. And at the end of the day, it'll say, okay, just add up the values that are left over. But it has a limitation that I will show you. 2 of them, actually. But let's try it. So, sum ifs. All right, what are we going to add up? Absences. If it meets what? Where are we going to look for the criterion? We're going to look for ELL, and then comma, then 1. Then student sex, comma, whatever's above it, and comma, grade, comma, 5, 6, and I can move it over and it's going to give us the same answer. So why don't I like it as well? The first reason I don't like it is because it's hard to understand what it does. If you have to go back and cross-check it, it just says range criterion, range criterion. I'm not saying, does this equal that? Like I did with some product. And I can't say, is this greater than that? Is this less than that? Is this not equal to that? My only options are the value in the range equals this thing. Could I do something like grade quotation mark greater than 4 quotation mark? Yes, I can do that, but it just doesn't read like natural speech to me. So it's a little harder to wrap my head around what it's actually doing, and it's harder to go back and double check it. Some product, does this equal that? Is this greater than that? But this is range, comma, criteria, range, criteria, range, criteria. So it's a little more complicated. But there's also something that we can use some product for that some ifs could not do. Let's say you don't have any criteria. You just want to take the values in one column and multiply them with the values in another column, or another 2 columns, another 3 columns, right? That's all I want to know. I just want to get a total count of all of column 1 times all of column 2. So let's say, for example, I have the number of students here, and I have how many absences those students have. So in this data set, 3 students have 5 absences. 10 students have 4 absences. 2 students have 3 absences, and so forth. So I could go the long way and say, well, 3 students have 5 absences. Oops, let me just do that. Equals 3 times 5. So that represents a total of 15. And I can copy my formula down. So my 10 students had 4 absences each. That's 40 more. And then at the bottom, I can just say, all right, add them all up, which is fundamentally what some product is doing. Or I could just use the sum product formula, equals sum product. Now check this out. This column times this column, 62. So it allows me to multiply all the values in one column against all the values in other columns without having to do all those extra steps. Some product will do that. Some ifs will not. So where are we? So that, frankly, that's all the stuff we did, plus a few more items from the first couple of sessions. But I made a promise that we're going to do a little bit of stats this time, and especially around that average. Because as I mentioned, average is kind of meaningless unless you know what the data look like, how much variation is in the data. You know, when I look at student assessment data for the state, I can say, okay, your average scale scores, let's say the average kid in the 4th grade is reading at the 3.8 grade level. Well, frankly, whoop-de-doo. The big question is how representative is that of any individual kid? Are all the kids kind of around that point, in which case it's useful, or are they just spread all over the place? So much variation, the average doesn't actually tell us anything about the kids. And the way we figure out whether or not the average is useful is by running a standard deviation, which I'll show you how to do because it's really easy. But let's just do a couple quick things. So what do we have here? We've got time to take the test, like how many minutes did they use on the test, and what was the resulting score. All right, that's good to know. Let me go ahead and name these. So this is times, and this, I'm going to call this S scores, just so it's different. S scores. Okay. So let's do a couple very quick things. All right, what's the average time? average of times. All right, on average, 47.86 minutes. Okay, lovely. Median, that might be useful to us. Let's do median of the range, which is times. And the median is like, what's the score, or what's the point where half the points are greater than and half the points are less than. If you have an uneven number of scores, it's going to be the exact middle point where exactly the same number above is below. If you have an even number, what it will do is it'll take the two in the middle and then average them. All right, so the average number of minutes is 41. Okay, let's do average of the scores. That's probably more useful. And median of scores, S scores. All right. Average score, 469 or 470. Median, 465. Okay. There's a couple things that we can very simply calculate. Sometimes you just want to know what the range is. Like, what's the highest? What's the lowest? Turns out it's really easy. So you want to know the highest value? It's just max in the range. You want to know the lowest value? What's the minimum? What's the range? Okay. So we'll do that. Equals max scores equals min scores. S scores. Now, to find the range, we could say, well, give me that value minus this value, and it'll tell me what's the overall range. But I'm going to just go ahead and put those into one formula. So max of scores minus min scores. The range is 235. We'll skip the midpoint. But that brings us down to that standard deviation, which is super duper important. And I would recommend this. If you're ever going to look at an average of anything, always run a standard deviation, because that'll tell you whether or not the average is meaningful or not. Let me show you an example. So let's hide that, and let me activate this. Okay, so here we have basically three data sets plotted on a curve. And you'll notice that for all three of these, the average is the same, right? Average is 50 in this case, right? But in this blue data set, all of the scores are very clustered around the average, which means that average score is fairly indicative of the overall data set. So it's useful. If the data are more spread out, there's more variation in the data, we might get this teal one here, right? Same average, but perhaps that average isn't as representative of the whole set. And then you got this orange one over here. The data are just so spread out with a big standard deviation. They're just so totally spread out that finding out what this value is right here doesn't tell us anything about these kids or these kids down here. It's not useful information. Same average, but its value changes depending upon the standard deviation. So we got to calculate standard deviation. Lo and behold, it is really easy to do. Standard deviation range. We tell that to Excel, and it'll give us our standard deviation. So let's find out. So equals standard, STDEV, and the range is S scores. The standard deviation is 60.9. Well, if the range is 235 from bottom to top, I would say that that is probably not very indicative. That's a fairly large standard deviation when you have a fairly narrow range of scores. There is one caveat here. When Excel calculates standard deviation, it assumes that you are looking at a sample of an overall population. So let's say, so here I'm in Farmington, and I send out a survey. I don't know how many people live here. Let's say it's 20,000 people in Farmington. And I send out a survey to 500 people. And I get 500 responses. That's enough responses that I can take those results and generalize to the overall population. But it's still only a sample. When Excel calculates standard deviation, it assumes a sample. But in a case like this, where we've got kids' scores, I have every single score. I don't have the sample of the kids. I have all of the kids, the entire population. So we modify this slightly like that. So STDEVP for population. And it will give me the standard deviation for the entire population. STDEVP. And the range, and it's slightly different. Okay. Bigger data sets, it's going to be more meaningful, but it is a little bit different. If you want to be accurate, you have to ask, is this a sample or is it the entire set of data? So it's very, very slightly different. I will throw in one last thing. We'll skip correlations. But the other thing that we generally need to know is how much effect does one variable have on changes in another variable. So I've got times and scores over here. I would want to know if kids are taking more time on the test, are they typically getting better scores? And if they're rushing through it, are the scores lower? So how much effect does time have on scores? And without going into the stats too deeply, I'm going to learn that by calculating something called the R-squared value. And basically, it's like if you made a trend line through all the data, how well does that trend line reflect the data? A high number, you can say that yes, the first item has a pretty strong effect on the second one. A low number, no, it doesn't have a strong influence on it. So I'm looking for a high number, basically. And by high number, I'm generally saying something that is at least 0.8 and above. And if it's less than that, it's probably a pretty weak effect. It's simple to do. RSQ and the range. Range 1, how much effect does range 1 have on range 2? And it will give me that R-squared value to tell me, does the first variable, how much influence does it have on the second variable? Equals RSQ. The first range times, which I have named. Second range, scores. And the answer is 0.36, which is very low. What I have just learned is that taking more time on the test or less time on the test is a very weak predictor of the score. And that is valuable to know. So that actually brings us right up to 3:33, actually, which brings us to the session. But one question I had this morning, and I'd be happy to address it if you're so interested, is can we plot this? Like, can we actually plot the points to make a bell curve or, the data curve in Excel? And there is a way to do that. So I realize we're at time, but if anybody would like to stick around and see how we do that, I'd be happy to spend the time to do it. But otherwise, we are good to go. And I will just make one last note. This video and all the other videos are going to be available wherever I put it on our website at that. It'll be going up probably later today or maybe Monday. It'll be going up. So you can always come back and take a look and find the video if you want to refresh it. But you're also always welcome to just send me an email, call me and say, can you please go over blank again? Or can you show me how to do this other thing? and I would be happy to help, because at REC1, we are here to serve you. So with that in mind, does anybody want me to stick around and show you how to plot?
David, I've just got a quick question.
Sure.
If you switch the range 1 and 2 on your RSQ, what question would you be answering?
Let's try it. So right now, range 1 is times, independent variable. Range 2, scores. If I reverse it, RSQ, let's do scores first, and then times. It is exactly the same. Because it's how much does one value serve as a predictor of the other, or how well are they going to fit the trend line? Because if one of those is basically X and one of them is Y, you can draw a line through them, a trend line, and then plot the points and see where do they actually show up, like this. So let me highlight those. Let me grab a scatter chart. These are going to be all over the place. Let me, this is not what we're looking for. Hang on, let me change the style, change type. Let me just do it this way. So there are all the data points, X and Y. If you do it Y and X, it's going to be the exact same. I can add a trend line, and this is going to be kind of cool. So there's my trend line. So how well does that trend line, how well do those data fit that trend line? I can come over here to more options, and one of the options is display the R-squared value on the chart. And the answer is 0.3636, which is exactly what we calculated. So switching X and Y is not going to make a difference, because it's going to create a trend line and it's going to match the data to those trend lines. Does that help?
Yeah, and then, but after 80, scores above 80, no, people who spent more than 80 minutes did get closer to the trend line.
Yeah, but there are very few of them.
Right. Well,
which is one of the reasons why that standard deviation is so low. It might be a little closer up at the beginning, but look at where the majority of those data points down there in the 15 to 80 range, and they are all over the place.
and just real quick,
Sure.
Is there a reason why you prefer Excel over Google Sheets, or would your Google Sheets be pretty much very similar?
Google Sheets will do all or most of these. You know, I haven't actually tried R-squared values on Google Sheets. It will do all the other ones just fine. There are reasons why I prefer Excel. For one thing, it's a lot easier to name ranges, and you can see how useful that is. It's a bit twistier with Excel, although they've made some updates recently to emulate Excel a little more. So I would hesitate to say much, but the fact of the matter is Excel is just simple. It has more functions, and they are typically easier to use. But I also do a lot of back-end programming when I'm building spreadsheets just to automate things. Give me one button to click and do a bunch of stuff for me, and it's very cumbersome on Google Sheets, and it's pretty simple on Excel. So I'm an Excel guy. The Google people are willing to, use my name in vain later outside of my hearing. That's fine.
Well, thank you, sir. I really, really appreciate your time.
Sure.
This afternoon.
Sure. A lot of fun. Somebody says, hey, can you spend an hour and talk about Excel? I'm pretty easy to convince, because I do it all the time. It's just super useful to me. And I love it. I just really love it. So thank you all so much. I appreciate you all being here.